Hiya, Mr. Sutton here with the Pre-Cal Honors 2-2 Part 2 homework solutions on synthetic division. To start this problem off, we're going to write down the coefficients of the dividend, the polynomial here. So that's a 1 for x to the fifth, 1x to the fifth. And the next coefficient, there's actually an invisible 0x to the fourth. Notice we skipped from fifth to third power here. So we need a placeholder 0 for the x to the fourth. And then we have the negative 7 for the x cubed. Followed by, oh, we're missing an x squared, so we need another placeholder 0 for that. And then this is 1x, so 1, followed by the 1 for the constant here. So those are our coefficients. And now, since x plus 3 is our factor, our divisor rather, that means that negative 3 is going to be our box number. So writing our line down here, we bring down our first coefficient of 1, times negative 3 is going to give us negative 3 up in this next column here. And then we're going to add that to the first row. So 0 plus negative 3 is negative 3. Negative 3 times the box negative 3 gives us positive 9. Negative 7 plus 9 is 2. Negative 3 times 2 is negative 6. 0 plus negative 6 is negative 6. Negative 3 times negative 6 gives us 18. 1 plus 18 is 19. Negative 3 times 19, let's see, that's going to be negative 57. And 1 plus negative 57 is negative 56. So we have a remainder of negative 56. That means that x plus 3 is not a factor. And then the quotient, we're going to have a 1 for that first coefficient, 1 x to the fourth, since it's 1 lower than x to the fifth that we started with. So we have 1x to the fourth minus, this is 3x cubed, plus 2x squared minus 6x. And then finally plus 19. For this problem, to answer all these questions, I'll use synthetic division. So let me write my coefficients for my polynomial. This x cubed has a coefficient of 1. And then we have an 8 for the x squared, a negative 20 for the x. And we also have to represent the constant. Since there's an initial invisible plus 0 after that 20x, we're going to write 0 for that last coefficient to represent the missing constant. And now for my box number, I'm going to use 2 because 2 minus 2 would zero out that divisor. So box number of 2. Leave some space, draw a line, bring down our first coefficient of 1. And now I multiply my box number by all those bottom row numbers. So 2 times 1 gives me 2. Now I add the top 2 rows to get the other bottom row numbers. So 8 plus 2 is 10. 2 times 10 is 20. Negative 20 plus 20 is 0. 2 times 0 is still 0. And 0 plus 0 is 0. That last 0 is a remainder. That's our remainder of 0. Since the remainder is 0, that means x minus 2 is a factor. So yes to that question. It's a factor of the polynomial here. And our quotient is going to use all these numbers down here except for the remainder. And it's going to be one exponent lower than we started because you did an x cubed divided by an x, so using exponent rules. So this 1 here is a 1x squared for the quotient, plus this is 10x, and this is an invisible plus 0 for the constant, but we don't need to write that. To set up this synthetic division problem, we'll start with the coefficients of our polynomial dividend. So we have a 1 for the x to the fourth, minus 5 for the x cubed, and then we have minus 13. And then after that, we're missing an x to the first power. There's a 0x to the first, so that's a placeholder 0 there. Finally, we have 10 for the constant. Our box number is going to be whatever zeroes out this binomial, so negative 1. And then drawing our little line and leaving a little room, we bring down our first coefficient of 1. And we're going to multiply all these bottom numbers by the box number. So negative 1 times 1 gives us negative 1. We'll put those products in the second row, and then we add the first and second row. So negative 5 plus negative 1 is negative 6. Negative 1 times negative 6 gives us 6. Negative 13 plus 6 is negative 7. Negative 1 times negative 7 gives us positive 7. 0 plus 7 is 7. Negative 1 times 7 is negative 7. And then 10 plus that negative 7 gives us 3. So this last number is our remainder of 3. Since that's not 0, that means x plus 1 is not a factor of the polynomial. And then our quotient, we're going to start with a 1 coefficient, and our highest power is going to be x to the third because we divided an x to the fourth by x, so it goes down an exponent. So we have 1 x to the third minus 6x squared minus 7x plus 7, and that's it. To solve this problem, I'm going to use synthetic division. So let me start with the coefficients of my polynomial. We've got a 2. We're missing an x cubed term there, so we have a 0 for the 0x cubed we didn't write. Then a negative 15 for the x squared, negative 10 for the linear term, and 5 for the constant. Since we have x minus 3 as a divisor, whatever zeroes that out is my box number, so positive 3 for that. Leave some space, draw a line, bring down our first coefficient of 2, and our box number gets multiplied by the bottom numbers. 3 times 2 is 6, and we add these top 2 rows to get the rest of the bottom numbers. So 0 plus 6 is 6. 3 times 6 is 18. Negative 15 plus 18 is 3. 3 times 3 is 9. Negative 10 plus 9 is negative 1. 3 times negative 1 is negative 3. And then 5 plus negative 3 is 2. That last 2 down there, that's the remainder. And then since that's not 0, that means x minus 3 is not a factor of the larger polynomial. For the quotient, we use all the numbers down here except the remainder, and it's going to be 1 exponent lower than we started. Since we had x to the fourth and we divided by an x, that means this 2 here represents 2x cubed, followed by 6x squared, plus 3x to the first, or just 3x, minus 1. For this problem, we're trying to figure out the remainder, whether x plus 4 is a factor of the polynomial and the quotient. So we'll start with synthetic division. To start that process, we write down our coefficients of our polynomial. So we have a 1x to the fifth, therefore our first coefficient is 1. Followed by, well, we don't have an x to the fourth, so there's an invisible 0 there. So that's a placeholder 0 for x to the fourth. After that, we would have an x cubed, but there's no x cubed either. So we actually have another placeholder 0 for the 0x cubed. We do have an x squared, so that's 54 for that coefficient. We're missing an x. Surprise! So there's another placeholder 0 for 0x. And then we do have our constant of 160. For our box number, it's whatever zeroes out the divisor. So that's going to be negative 4 because we have x plus 4 here. So there's a little bit of a space, a little line down there. And now we'll bring our 1 down to the bottom because it's the first coefficient. We'll multiply our box number of negative 4 times our bottom row. So negative 4 times 1 gives us negative 4. That goes in the second row. And then remember, we're adding the first and the second row together to get the rest of the bottom row numbers. So 0 plus negative 4 is negative 4. Negative 4 times negative 4 is 16. 0 plus 16 is 16. Negative 4 times 16 gives us negative 64. 54 plus negative 64 is negative 10. Negative 4 times negative 10, that's 40. 0 plus 40 is still 40. And negative 4 times 40 is negative 160. 60 plus negative 160 is 0. So our remainder is 0, that last number. Since we have a remainder of 0, that means that x plus 4 is a factor of this polynomial. So that's a yes for the is it a factor. And for the quotient, we're going to start with an x to the fourth term because we divided an x to the fifth expression by an x, so it's 1 exponent lower. So we have 1 x to the fourth using these coefficients down here, minus 4x cubed plus 16x squared minus 10x plus the constant 40. And that 0 was just our remainder, so it doesn't get thrown in with the rest of this. And we are finished. On this one, we're trying to divide x squared minus x by x minus 3 to find all this information. I'm going to use synthetic division. So let me start with the coefficients of my polynomial. We have a 1x squared for that first coefficient, so 1. Minus 1 is the next coefficient there because of minus 1x. And then don't forget we have a placeholder 0 for the missing constant. There's an invisible plus 0 at the end. So we represent that with a 0 in our coefficient row. For the box number, I'm going to use whatever zeroes out this divisor. So that's going to be positive 3 because we have 3 minus 3 giving us 0. Leave some space, draw a line, bring down our first coefficient of 1, multiply our box number by the bottom row. That'll give us our second row. So 3 times 1 is 3. Now we add the top two rows to get the bottom row. Negative 1 plus 3 is 2. 3 times 2 is 6. 0 plus 6 is 6. That last number down there is the remainder, which is 6. Since that's not 0, that means that x minus 3 is not a factor of x squared minus x. And for our quotient, it's going to be these numbers down here except for the remainder. And we're going to start one exponent lower than we started with in the original. So since we started with x to the second, that means our quotient has an x to the first. So this 1 really means 1x to the first power plus 2, and that's it. For this problem, we're trying to figure out if x minus 1 is a factor of this polynomial. To figure that out, we need to know if the remainder, when we divide the polynomial by x minus 1, if the remainder comes out to 0. But we're not actually going to divide, because the remainder from dividing by x minus 1 using our remainder theorem is actually the same you would get if you just plugged in positive 1 to this polynomial. If you just plugged in whatever your box number would be to the polynomial, you end up with the remainder. So we're just going to plug 1 into all these x's. So we have 10 times 1 to the 65th plus 4 times 1 to the 13th minus 14. Well, 1 to the 65th is just 1, so that first term is just 10. 1 to the 13th is also just 1, so we have a plus 4 then. Still have the minus 14. 10 plus 4 is 14. 14 minus 14 is 0. Since we have a remainder of 0, this is the actual remainder you would have gotten with synthetic division. That means that yes, x minus 1 is a factor of this polynomial. On this problem, we want to know if x plus 1 is a factor of this massive polynomial. Now, the good news is, to figure out if it's a factor, we just need to know the remainder by dividing by x plus 1. And the remainder theorem says that whatever you get by dividing by x plus 1, it's the same thing you would get as if you just plugged negative 1 into the original here. So I'm going to find the remainder by just plugging negative 1 in for x in the original polynomial. So we have negative 1 to the 36 minus 4 times negative 1 to the 27th minus 7. So just plugging negative 1 in everywhere. Negative 1 to the 36, well, that's just negative 1 to an even power, so positive 1. Negative 1 to the 27 is still negative 1. Times negative 4 gives us a plus 4. And then we have a minus 7 after all that. 1 plus 4 is 5. 5 minus 7 is negative 2. Since that's not 0, that's our remainder now. Since our remainder is not 0, that means that x plus 1 is not a factor of the polynomial.